compressors, and an analytical process they use for that to start is mean line design. And really, nowadays we have simulators that can actually simulate the geometry and give you back parameters that can actually tell you how efficient something is. And that's what I'm doing right now. But the problem is simulators take a lot of time. And there's a lot of different reasons for this we can get into if you're interested. But mainly, the problem is that they're slow. And to be able to do what I'm doing, you need to have a approximation of simulated results that you can actually use to do a lot more design iterations. Because tuning geometries takes a lot of iterations before it can actually derive some sort of meaningful intuition from it. So, for example, like things that when they use AI to like try and learn how to drive or play a game, it usually runs into like maybe actually how to play that game or drive anything meaningful in like the hundreds of thousands of iterations. Like, for example, a racing game, it would just keep smashing into the wall until eventually it realizes that's not a good thing to do. So you actually need a way that you can run simulators fast, because not only are experiments in real life fast, but simulators are also not fast. So what I'm trying to do is create a new type of simulator called a differentiable simulator. And what that does is you essentially keep track of every step of the simulator, specifically the rates of change of like different parts of the simulator. These are called gradients. And trying to make machine learning models based off of all of this data from a bunch of simulations to make a model that can actually predict the simulator itself. Once you can do that, you can actually run like orders of magnitude more simulations. And this has been done already in, so for example, there's a project called AlphaFold where protein folding simulations take like literally a week's, depending on what you're trying to solve. And they made a model with high levels of accuracy in the 90s or 95% accuracy that was able to actually predict these very, very costly simulations in like a matter of seconds or minutes. And so even like at Facebook AI Research, I know someone there that's working on Open Catalyst, and these quantum simulations, what they're trying to do is they're using quantum simulations to essentially try to find a new type of catalyst for chemical batteries. And these quantum simulations take like literally weeks to run with current analytical methods. And so they're actually able to take in a lot of the sim data and make models, particularly with like these things called graph neural networks, to pretty much make an approximation. And now they're thinking about using this for things like drug discovery and all kinds of things, not just like the original intent of the project. And so I'm trying to do something very similar, but with Navier-Stokes type equations. So stuff for like fluid dynamics, for thermal conduction, all kinds of that kind of stuff. And so I'm getting pretty far and trying to understand like how simulators work. And then very soon I'm in the process of actually implementing those simulators as well. But currently what I've done so far is I have a framework that, automates all of the geometry generation for like the blades, like the CAD, like literally I can just take a bunch of specs and I'll just literally output all of the CAD for like, say, a compressor, all of the bill of materials, like for screws and everything. And so now I'm in the kind of middle area where I can do the geometry generation. Now I'm actually trying to simulate that environment. So that's a little bit of a long overview, but that's what I've been up to for the most part.
Interesting. So if I were to sum it all up, I think what I've got is that OpenRI is basically where you're trying to build a software that learns through machine learning, like which simulations are wrong, why they're wrong, and to completely step away from those type of simulation attempts and go to the other ones to get the right simulation.
So it's not that simulators are wrong per se, it's that they're slow. And the thing is, simulators themselves are also approximations. Most simulators use this thing called Navier-Stokes, which is pretty much just a re-implementation of like force equals mass times acceleration. But instead of mass, you are trying to do momentum. And so what I'm trying to do is make this thing called a surrogate function. And what a surrogate function is an approximation of something that is slow, but is good enough so that you can get the majority of design iterations in a shorter amount of time. So I almost see it like a funnel, right? So the most costly thing is real world testing. And then the second most costly is simulations. And so if you had a way to approximate that, you can get through way more designs and kind of funnel out most of the designs until you actually get to a point where, okay, maybe I have like a few thousand design iterations that seem like good candidates, then just run good real simulations on those. And then maybe the best 10, you do real world testing on those. So that's the approach.
So your software is basically going to save a bunch of money for these companies.
Yeah, and I have friends and people I know that, for example, there's this person at the Turbo Machinery Initiative at UIUC, and they're actually doing something very similar with rocket pumps, where they're able to parameterize all the pump geometries for, say, like a centrifugal pass or like the blades of the pump. But the difference is they have supercomputers to run all these simulations, and most people like myself don't. So if there's a way that you could actually be able to do the same amount of computation or design filtering, then that would be ideal. So you don't need to be a SpaceX to be able to run like, simulations for a grid fin for like, say, the fins on the rocket that you need a whole supercomputer to run. You could essentially get to a place you want with way less compute, and then maybe refine it with real sims once you get most of the design iterations down. So that's the approach here.
Interesting. Okay. And I'm more interested in like how you got into this, because this seems like a very niche topic. Like
Yep. Yeah. So, I wonder how so as well. So I think I got interested in general. It was my last semester of college. And like most people, I like hold off my elective classes towards the last semester. And so I think with that comes the wisdom that you learn from your actual degree. And I predominantly was learning stuff with machine learning, and, I had like I did computer engineering, but I could learn a lot of stuff in CS as well. And so I knew I had like a very good understanding of machine learning at that point. And so in the statics class, we had to design like a bridge. And I remember like the task was like you had like, let's say, 20 newtons of load that you had to support with this bridge. And you had to essentially make like a truss system to support this. And traditionally, like in the class, what people would do is they just kind of try random variations of a truss configuration and essentially do moment of joints to calculate the net force on each node in the bridge. And they'll just do this like until finally like, okay, finally it supports 20 newtons. I'm done with this. And I was like, I am not doing that. That sounds incredibly like a waste of time, and like also not very optimal. And so what I did is I actually just had the computer already just taken any sort of mesh truss configuration and calculate the moment of joints, and to get the net force on each node. And then I used a genetic algorithm, which is a type of minimization function that would iteratively try random variations of the truss and calculate what the net force it could do. And I left this running overnight. And the next day, I literally was able to support like 75 newtons, and we only had to do 20 or so. And it was the best bridge in the class's history. And so I realized at that point, like, I'm very interested in using computers to design things. They can design things way better than any human can, just given the correct algorithms. So then I joined on board with Tesla, doing pretty much the same thing. I was on the digital experiences team on the energy side, and we had to like write things that would optimize batteries or optimize solar placement or solar panels themselves. And so I was actually using a lot of the same machine learning algorithms to optimize things in industry on the energy side. And so actually, I ended up getting specifically into aerospace. I was always really interested in aerospace, but I think the thing that really sparked the passion for me was I saw this video by Found and Explain, which is like a YouTube channel about this plane called Star Raker. And I guess the point of its inception was that there's like the energy crisis, and they needed a way to like take a lot of things to orbit. And they wanted to set up like, say, space-based solar power stations, because solar in space is like a lot more efficient. And the thing that I found so cool about that, it was a single stage to orbit vehicle. It had 5 jet engines, I think, and like 3 rocket engines. And it was able to pretty much in the lower atmosphere work like a normal plane. And then once it got to the upper atmosphere, it toggled these rocket engines. It was able to, and then after it was deployed all its stuff in orbit, it was able to kind of go back down and land like a regular plane. Eventually, the funding for this got cut, but I think the space shuttle like was kind of its predecessor. But I just found this concept was like, very cool. It really like kind of ignited a passion in me. Like that, I was like, I want to do that. Like that was the coolest thing I've ever seen. And so afterwards, I was like, okay, I guess I could like maybe try learning how like jet engines work. Maybe I can even make like a little model of it myself. So I got like 3 or 4 textbooks on fluid mechanics. Specifically, the book I got that was the most helpful was Fluid Mechanics and Thermodynamics by S.L. Dixon. And there's also another one, I think it was like Axial Compressor Design by Ronald Ongear. And just went through every problem with this book and just taught myself. Like I just went through every homework problem, did every one, and then I used Chegg to like check myself to make sure I was actually doing this correctly. And then I got to a point where I was like, okay, I actually understand like how to do this. So I started like programming algorithms that I could just give it an input spec and it would just straight up calculate all of the cascade geometries, all of the velocity fields, all velocities and angles and everything, and just spit out like the geometries of that blade that should ideally be there analytically to give you the correct pressure. For example, I started with the compressor because that was the easiest. Then with a jet engine, you have like essentially a compressor and then the combustion chamber and the turbine. And so I started with the compressor just because it was first. But a lot of the same stuff applies to turbines. It's just in reverse. So I got to the point where I wrote a substantial amount of code that I would just take in and then just give you back the specs of like what the geometry should be. I was like, okay, I want a way to like visualize this now. And so that's when I kind of started getting to generative CAD, where I was like, okay, I have all these numbers. I want to generate literally like a step file or an STL file. I actually want to like 3D print this stuff and see like what it looks like. And so there's like quite a few generative CAD things that all sucked. I eventually converged toward this thing called CAD Query, where you could literally just take in coordinates and like parametrically generate all the CAD. So you could give it the coordinates, extrude it, attach it to a disk, essentially make like everything that you could do in like SolidWorks or like Autodesk in code and then generate the CAD. And now I'm at a point where I have everything done, like what the textbook definition says analytically you'd want to make a compressor. Now I'm like at the point where like I actually want it to be optimal. Like I got to this fixation, which is like, maybe this isn't just a side project. Maybe I'm onto something here. So eventually now I'm actually trying to use simulators to validate. And the nice part about this is like, it's all end to end. There's no like, okay, I have a team of engineers doing the design side, another team that you give them the designs and they do the CAD modeling. It's all end to end within one program. And so that's where I'm at now, where I'm trying to use simulators to validate. And I have like a bunch of stuff running right now that's just like trying to optimize the geometries. But I'm actually trying to now like make a faster simulator. So that's kind of where I got to this point, which is I want a way that I can just run this end to end like a normal computer and be able to get something that's an equivalent of what an engineer could design. So yeah, that's kind of where I got here.
That's so interesting. So it's like you're basically removing the world's needs of using a supercomputer for everything, and you're getting this thing on a normal machine.
That's the approach. Yeah.
Interesting. And
maybe like slightly better than a normal machine. Like if I could just run it on like a desktop with like 2 GPUs or something. That's like
that's still
the approach.
Pretty good.
Yeah, that's the idea, which is I want to make this very. The other approach with this is so the reason why it's called Open Orion is I noticed that there's just a lot of gatekeeping in aerospace. Like as a software person, like I'm used to being like, okay, my text editor free, my programming language is free, my the libraries I use are all free, and that's why you see so much like value and growth in software, because just starting out isn't have all of this cost and barrier to entry. And so, but it's not the same with engineering. Like for example, MATLAB, if you're not in a school or a big company, it's like literally thousands of dollars just to start with a programming language. Now you talk about like ANSYS, and it's like, I think $30,000 a license just for a simulator. And like all the open source in the space is like not very good. So people kind of default to commercial. But the problem is like, so some people say like, okay, well, for some ANSYS program, it's like, that's just a drop in the bucket of hardware cost. It's not a big deal. Well, if it's someone like me that's just starting out as one person, dropping $30K for a license is a big deal, even though like, once you get investment and a group of people, like it's, not a big deal at that point. But it's just starting out, that's not okay. And so what I was saying is, okay, I'm going to make everything I do open source. I'm in a position to do that. And so far, I've made like a lot of tools that are free and are very capable. Like I have researchers at like various places like Stanford, TUM, SU2 Foundation that are using my tools to automate their mesh production. Meshing is like a big thing in simulators, which is like taking a geometry like a CAD file and like discretizing it into a bunch of cells. Like current meshing, like Gmesh, is like very hard to use. I made a way that you could essentially just in Python get started in like a Python notebook and just like pretty much generate a mesh in like 5 minutes, and it's very easy to use. And another thing is like, just using a simulator, even a normal simulator, not even like the new one I'm trying to make, is very hard. I made it so that you could just literally say like, hey, is the mesh that I generated, and here's the inlet, and it's going to have like this condition coming in. Now simulate it, and it just gives you back like a NumPy array in Python of like all of the results you want. And it's like super easy to use. And that was the approach with this, which is like, if there doesn't have to be complexity, then make it easy. And if they want to be able to make it like apply more like advanced configurations, then also make that very easy to do as well. So yeah, that was kind of the approach too, which is like aerospace and also engineering is just very gate kept. And so I was trying to make it so that all the tools in this project are also open source.
Interesting. Yeah, I agree. Yeah. I really like the approach that you're trying to make it open source and not gatekeep things. Because I completely understand that part.
Yeah, I mean, like the thing is like, okay, if I do all this work and maybe I make a quick buck on my own in industry, whatever, then like every single person that wants to do the same thing now, they have to start from square one. Like, just imagine like the equivalent with like aerospace, like trying to do something as hard as getting to orbit is like someone trying to make an app and then they have to start from writing iOS. Like that's the equivalent to me. Like even having the operating system or like the IDE or anything, like something, a heart of a problem like that is like the equivalent in software. Like, so it just seems very dumb to me because I think just the baseline shouldn't be that big of a leap in as far as like human time is concerned. I think we can think of greater problems once we actually get to a baseline that's generally agreed upon. So yeah.
I really admire that. Trying to basically democratize this, because eventually what your software is going to be able to do is like it's going to fuel these people to do the things easily, and it's going to fuel up the innovations by like really high magnitudes.
Right. Yeah. I hope so. Yeah, that's the approach.
Cool. And I wanna ask you more about like I get the sense that you got this idea for the software in the class with that one experience trying to optimize the trying to get like 20 newtons for the bridge. I want to ask like how you basically got to engineering. I want to know more about how your interest in engineering just started, and I want to know more about like in your childhood, like what your whole story is about.
It's an interesting question. I was always like interested in building things as a kid. I just remember like having like a really big imagination of like spaceships and all that kind of stuff. And so I was always really interested in this concept, and I was like building a plane. I remember my cousin came here and he was like, we were building like wooden model planes, and I was like, I want to build like a real one when I was like 4. So that's always just been something that I've always been interested in. But like, I think the thing that really got me into the space was I remember I think like I saw like the first Iron Man movie, which is pretty cliche engineer story, but I was like, that's like the coolest thing ever. And so the first thing is like I was very interested in like building electronics. So when I was like 12, I was like building these circuits and trying to like, for example, you know, turn a motor or like, you know, actuate like a servo. And so I was doing all that. Literally in like the 7th grade, I was trying to build like a solar plane. And I had all these little solar cells that I soldered together and had this like motor controller. It never actually flew because it was too heavy, but I had the effort at least. And so like, as far as like the Iron Man thing, so I was trying to build also like, I think in middle school, this was like way before like any of like the Alexas or like any of the voice assistants we have now. But I remember Google had like this early voice recognition API. And so I had something where I could literally like transcribe the text that I was speaking to it through that API, and then like building out this conditional tree of like things it would reply back and like talk back to me in text to speech. And so I built my own like voice assistant. And like the other thing I wanted to build was really cool was like a heads up display. So I had like I just got a 3D printer in 8th grade. And so I built all these like little headsets things that like it would have like a screen here, and then it would like reflect onto this film. And I could literally see like a Raspberry Pi like display like right in front of me. So I was building like all kinds of this stuff when I was in middle school, high school, like my own watch, all kinds of stuff. And so it just seemed like a natural progression to kind of go into it. And I chose computer engineering because it seemed like a good balance, because I was programming all throughout high school and middle school. So I actually wanted to learn more of the hardware side as well. And the nice thing about my program at Georgia Tech is they let you really take they changed it recently, but really any CS or EE class you wanted. And so then I went in and just learned as much as I could. So I took like malware analysis and computer animation and graphics and everything that I could get my hands on that seemed interesting. And so, yeah, I think that was like a pretty good experience, just getting an overall view of all these fields. So
that is so cool. I mean, that's so cool. You started building your own plane in grade 7 like that.
Yeah, I can give you a picture if you want.
Yeah, sounds good. I'll take it. I'll display it on my Instagram with these when I post for the podcast. But yeah, that's super cool. I'm curious, like, how did your parents support you when they saw you like trying to build these things and stuff?
Yeah, I mean, they're just kind of like, I mean, at some point they're just like, this is kind of how our kid is. He's very interested in these things. So yeah, I think, yeah, I guess at some point they just became used to it. So, nothing to say there. I mean, like, I remember like I'd always like have them drive me to Radio Shack or like Fry's Electronics, and I'm just like literally like a 12-year-old. So I'd just be going through all these chips and things. So yeah, I think at some point they just got used to that idea.
That is so cool. So you had more like, instead of like having a like a normal high school experience, you were always building things. Like, that's what I'm getting from that, right?
Yeah, I remember like legit. It was a really awkward experience, but like that kind of shit. So it was an interesting experience for sure.
That is so funny. Holy crap. That's so sick. And I want to ask, with all this building stuff, like, how did you find the time for doing this? Because I mean, the audience that's listening to this, it's mostly like high school or college kids, and like a lot of times the problem is like the school has so much of your life consumed, like you're just like trying to get the best grades and stuff. So
yeah. I'm gonna be like pretty frank. I didn't really care. I mean, I have a very good memory, so I actually did pretty well in school, but the majority of my time was actually just doing side projects. Most of my weekends and like during the week, I was literally just trying to make this Jarvis GUI thing that like I could put on my overhead display thing I made. So like I remember like not really actually spending, like, maybe if there's like a test coming up, I would just like cram, but like I really didn't put a lot of value. Like I ended up getting like a pretty high GPA, but like I didn't actually spend that much time like doing stuff in school. Mm-hmm. I remember like my mom's like, don't you have like a test coming up? And I'd just be like, fucking around with something interesting that I thought was cool. So you know, it was definitely like a different experience, I think, for sure.
Nice. That's super cool to know. And I mean, this is like, feel free to like touch this a bit or not, but I'm curious, like, do you have any tips for like people who are like like my age, like in college or like in high school, who are just like finding it hard to like carve out time? Like, if you have like any specific habits that you feel like you adopted that was able to
Yeah,
like, yeah.
I think there are a few things. I mean, one thing I did have was like I was very good with time management. So I am very good with like taking in like, okay, what needs to be done, and then delegating tasks that, so for example, you have a test coming up and then you have like another assignment and then, maybe a project due. I'm really good with like kind of saying like, okay, assessing like, well, this is going to take that amount of time. And that's just something you have to know about yourself, of like how well you work and how fast you can work. But I was pretty disciplined in like allocating time and being able to know how much time I should spend on something. Because quite frankly, like at the end of the day, like if you have a bad professor, or or if a class isn't going well, in my opinion, like you're probably going to get a bad grade. If you like, obviously there's like a good medium. Like, if I study this much, I'm expecting to at least get a B, for example.
Mm-hmm.
But like, there's just kind of classes like that where it's like not even worth putting like 5 days into it, because like a lot of times in my experience, you end up just getting the exact same grade, to be honest. So I think in my experience, it was like taking in like all of the parameters of the class and like all of the problems that you've done in class and just like mastering those algorithms, and doing it enough that you're confident in yourself, but not doing it enough that's like, okay, it's excessive. Like at least allocate time to other things that are useful as well. Because I think regardless, like if you have a good professor, I think you're going to do well. And if you have a bad professor, no matter how much you study, you're probably going to do bad. Probably because like bad professors, they give you problems that they didn't even like cover, make excuses. So I think if you actually have a good professor, it can actually, if you actually put the work in, you're going to do well. And that's kind of what I've noticed in my experience.
Yeah, really get the part about like allocating the right amount of time and just knowing that, because I feel like I personally struggle, and I know people who struggle with that, because it's like you have like a gazillion things on your to-do list, and like it generally isn't gonna get done because in the past days, well, you haven't spent your time efficiently and you're overloading yourself with too much of expectations. Like it's just like such an extension of like, if your focus is gonna be that long, if you can only focus for 15 minutes and you do need a break, it's just so important to like get the measure of time you're gonna spend on that. Like for example, I do this thing, like if I think this assignment's gonna take me 2 hours to do, I allocate myself 4 hours to do, because I just know I'm not that reasonable, like giving myself time. And I think that's something that's worked for me pretty well. So just want to put that out there. Do you relate
definitely
with that?
definitely everyone's different. But like, I mean, if you're a procrastinator, I don't actually think that's a bad thing, quite honestly. I think like the founder of Netflix was literally saying like procrastinators are actually the most creative people, because sometimes if you have a lot of time and you start early, sometimes like you actually do something that's not very optimal because you're not time constrained. But if you are time constrained, you're going to actually try to do methods that are a lot more efficient to get to the same exact result in a lower amount of time. And you actually see this with a lot of optimization functions, where if you actually like tune the problem in a different way, maybe you make time the objective function, you actually start doing a lot more creative things that you wouldn't have thought of before. So I think the stress of time isn't necessarily a bad thing, at least for sometimes optimizing things better, which has happened to me a lot. Like a lot of times, like for me, like for example, if I have to do some boring presentation or like a pitch or something, I usually don't actually get started until an hour before, because it actually puts that time pressure on me. And I'm actually like in this moment of Zen where I'm like orders of magnitude more efficient than normal. I don't look at my phone at all. I'm just like completely all in on getting this timeline like done. So that's an interesting approach also for work, and
Nice. Yeah. I want to touch a bit more about this before we dive into the other parts because I feel like a lot of my audience, like they struggle with procrastination, and I know I do. And I want to you said that you don't struggle with procrastination too much, like apart from these like pitch or like something
Yeah.
boring you have come up. So I want to add, I would just want to like ask, how do you tackle procrastination? How have you come to a point where you don't procrastinate in a lot of your tasks? Like, was there like a change or transformation you adopted, or you've always just been like that?
Quite honestly, for me, I think if the problem isn't boring, I don't tend to procrastinate. And the problem is a lot of stuff is boring. And so I've noticed, like, for example, a lot of the stuff I'm doing now, I'm like all in, I'm like just have my whole head in it. And I tend to have a lot more discipline. I think procrastination starts arising when you generally don't want to do something, or at least the way you're taught it is not in a way that really shows a lot of relevance,
Hmm.
and you just don't want to do it. And actually, I've been reading a lot of things like evolutionarily that actually makes sense. Like if something doesn't actually make sense to your survival, then like why do you want to do it? And so a lot of times I think, you know, if you can actually find a point of relevance for why this is important to you, then that's honestly what I do a lot of times. I remember there's a lot of times at work where something was incredibly boring, and I actually had to find a way to okay, if I like tell my manager like, hey, can I use this approach for this problem that I can actually learn something to do something else, then that actually makes me have an incentive to want to do this problem. I remember there's like a problem with like trying to optimize solar placement, and they wanted to do this incredibly boring and like non-optimal way. And I was like, well, I can at least use this to learn how genetic algorithms work better, or learn how minimization functions work better for this jet engine project I'm doing, for example. And so I also had another class in college. It was just incredibly boring. It was like something to do with supply chain. I don't even know why, because it was like a it was like a final project for like a senior design, but we had to learn it. And there's some stuff in there with like, it was just so boring. And so I just like legit was just like, okay, I'm just going to program these algorithms because like that's the only relevance it has for me. And I'm going to use this framework that I always wanted to learn because it's pretty similar to the space. And so that's how I added relevance to this incredibly boring task. Because maybe the task is boring, but maybe the other thing that you're learning to accomplish this task is actually relevant in a way that motivates you to do it. So that's how I've been able to encourage myself to learn boring things that aren't very relevant. So, I think that's my approach.
Yeah, no, I really admire that. Actually, I actually love that approach because it's something I've started to realize that happens with myself too. It's like if I don't care about something, like even if I tell myself something superficially that I need a good mark in a course or something, it's almost like I'm not being honest to myself. And until you have that sense of honesty with yourself, that you're doing this for a sense of curiosity of something that you said, like some sort of relevancy, something that ties back into your own why of things and your
Right.
own interest, that's when like things start to ramp up. You put it off. You don't put it off. You put off Netflix and you put off like your phone and stuff to do this task just because
Yeah.
it's so relevant
Yeah.
to you.
And that's why I think project-based classes are the best way to learn, because you're actually shown why these, really abstract concepts are actually really cool. I remember the best class I had in college was this class called GPU for video games. And what we had to do was literally build a GPU pipeline, like a graphics pipeline from scratch. So like how do games work, right? You have like a geometry and you have lighting and you have like all these different things. And at the end you get this like bitmap display of what you're seeing in the game. And so that whole process is like you have perspective transform and all these different things you do with like matrices and all these like matrix operations, dot products, and all this stuff eventually to get to this point. And we did all this from scratch. And this guy had an incredible lecture. It's actually on YouTube because it was during COVID. But he essentially just went through every single step of like, how do you make a video game engine? And we did this from scratch. And that was like probably the best class because not only did we learn a lot, like how to do shaders, how to do, lighting, how to do all this stuff for video games. But also we learned a lot of like the algorithms underlying in these processes. And we learned that because we had to do it. And that kind of established like, okay, that's how this equation is relevant, because when you get to this stage, then you need to apply this part. And so when you can kind of actualize the problem in a very like defined way, then things actually make sense in their relevance. That's why I kind of have a problem with like a lot of these prerequisite classes, because you don't really establish relevance till like later down the line. And a lot of times you end up just forgetting that altogether. I like to learn in a way that's like you kind of target the problem head on and then you start branching out the prerequisites, because then you only learn the prerequisites that are relevant. And also like you learn why those prerequisites are relevant. So yeah, I mean, I've learned a lot of like math that I didn't know before this project. I didn't know like what a Hessian was, or I didn't know what a gradient or divergent function was. And so I learned all of that because of necessity. And that's, I think, the key in learning something and actually understanding it, because your brain makes connections. And if these connections aren't made, you're going to forget it anyways. So, yeah.
What would your advice be to people who like were sitting in a prerequisite class and they're hitting it all together because they can't find any sort of relevancy to that continuing down in their path? Like, I'll give an example for this. If someone wants to go in front-end engineering and they're working in their computer science class and they're making linked lists and back-end stuff, and they're like, I do not care about this, what would your advice for them be?
I do a mini project that uses that. So if you're doing a linked list, what's a great use of a linked list? I know like page ranking, for example, a search engine uses linked lists a lot. Literally just ask ChatGPT, how is this useful? What do they use this for? It'll probably give you 10 reasons why. Pick one of those, program it, and you're like, oh, okay, that's why that's useful. Instead of iterating this whole array just to get to like the 1,000th element, which is incredibly wasteful, I could actually just go straight there and iterate down the line just through a pointer. So there's like a lot of different ways that you can learn these concepts a lot better. And so I think that's the main approach here, which is, like actually establishing why it's relevant. So, yeah.
Yeah, I really like that. And I do feel like it takes a bit more of effort to look for these things. Like, for example, looking for the page ranking algorithm. But again, it's like after you like do that project, I think it genuinely motivates you to do things, even though you have that initial resistance in the starting. Like, for example, I'm taking linear algebra in the summer right now, and the professor started with teaching us like just basic stuff like vector geometry, and then going the methods like Gaussian elimination and stuff like that. And I could not figure why the hell am I doing that, because it's also prerequisite for me. And I came with this approach that I just went on YouTube and I was like, okay, why is linear algebra useful? And I found this video by this dude named Zach Starr, and I watched the video, and in that he taught how Gaussian elimination is actually used in Photoshop and Adobe Premiere Pro to apply Gaussian blur. And that just blew my mind. Like, it genuinely felt so interesting. So
it's actually interesting you even say that, like in the relevance to ML. Like, have you heard of like convolutional neural networks, for example? Like, I
haven't, no.
Yeah, so convolutional neural networks is like how they do a lot of computer vision. So, for example, like detecting what a cat is. And the way that works is like very similar actually to a Gaussian blur, which is like essentially like you have this array, like a grid that's scanning across the image and doing what's called a convolution. And then these convolutions then go into a neural network, and they can actually like tell you what this image is, like a cat or whatever. And the way it does that, it's actually able to like localize all these pixels the same way a Gaussian blur kind of scans across, takes the local points, and then kind of averages them. It does the same kind of approach, and then it's able to like, that's why you're able to take in like many different angles of like a cat or like different colors, and it's able to tell because it's able to localize all these pixels. And so like there's just so many use cases of that, for example. But the problem is I don't think a lot of people really mention why it's useful.
Hmm.
And it's easy to like be like, okay, why the heck are imaginary numbers useful? And then you realize like all of telecommunications today and electromagnetics and everything is because of that. And so I think that's something professors need to start doing more for sure, is like establishing relevance. And I think that'll be a game changer and actually like sparking interests.
Hmm.
So yeah.
Yeah, I 100% agree with that. Like the project-based approaches and yeah, just finding these things where you see the application of your learnings from a broader bird's eye point of view, it's incredibly motivating because you get an end product of what you did rather than just like a bunch of papers in your notebook that are just filled with
Yeah.
solving a bunch of questions. 100%
Right.
agree with that. And yeah, I to double down on ChatGPT, I feel like a lot of people still don't understand how powerful of a resource it is.
Oh yeah.
Like,
I've learned so much stuff from like, here's the thing, like I don't 100% trust ChatGPT because sometimes it can
mhm,
hallucinate, but it is probably the best uh like uh, search engine for what I want. Sometimes you
mhm,
have some problem you're trying to solve and you don't even know how to like start even searching for it on Google.
mhm,
And so this actually does like a really good job at indexing all the core components of something that you can actually go and then do further investigation on with like books and search engines. And so I think definitely it's a very good tool for at least like making those connections and actually bringing relevance to all these different concepts, which otherwise you would have to like do a lot of investigation on your own to do otherwise. So yeah, for sure.
yeah, I can't emphasize.
I wish I had that during my college years for sure. I think the best thing I had was GPT-2. I remember there's this website called Talk to Transform, and it was like
Mhm,
all it was just like a really crappy text complete at that point,
mhm,
GPT-2. And even GPT-3 was that, but then they eventually did all this other stuff like reinforcement learning and trying to take the best responses and curating them, and they kind of converged towards like ChatGPT. But when I was in college, I didn't have like any of that.
mhm.
I remember I used like GPT-2 like a little bit for some class essays, but it was not even close to that point.
Yeah, I can't emphasize enough how much. Like, I think the best was truly, like you mentioned, is like indexing because like
Yeah,
it removes that initial resistance you have. Like the other day, I had an idea that I want to make an extension that basically goes on YouTube. Like whenever I open YouTube, it hides all my recommendations so don't get distracted. And I had that idea, and I'm like, I know Python and Java, and I don't know where to start from that. So I literally just told ChatGPT my whole idea, and it gave me like the instructions, and it even gave me some code. And then,
yeah,
like in half an hour, I had a working extension, and that just blew my mind that I
yeah.
was
It's
able to
very
do
good for
that.
generating code. I use it like every day.
Yeah,
It's very good for writing emails.
I
It's
agree.
very good for really anything involving text. Only times it kind of hits falls when like you really have like a very very abstract problem that takes like a lot of work, and it's not very good at that. Like if I ask it to write like a finite element analysis simulator from scratch, it's not going to do a good job.
Hmm.
But if it's a very common problem, it's usually does a pretty good job with like high accuracy in my
Hmm.
experience.
Yeah, I agree. 100% agree. Recommend people ChatGPT for that reason.
Yeah.
And, and I want to switch gears a bit. I want to ask, like, I've learned a lot about like your whole journey about getting things, building and breaking things, and like your experience in college. And oh, I can't forget the girlfriend. Like the thing that you gave to your girlfriend. That's super cool.
Oh, it
Or the
wasn't it
girl.
wasn't girlfriend, but yeah.
Okay, we didn't get to that point.
Yeah.
Yeah, no problem. Okay, that all that's super cool, and I'm more interested like to know that usually when people are building these things, I think one of the major things that I've seen that motivates me too is like being around people who are like very like-minded. Like if people around you are building these kind of things, it just fires you up. Like you look at them like they're going after something that they absolutely are passionate about, and they're just putting their 100% in every single day. And
Right.
I'm curious how like if you have found these people in the past, or if these people live with you today, or you're connected to them, how did you find them? And if you, what's your advice on for people for finding
finding similar like minded people?
Yeah.
Honestly, some of the coolest people I found today has been through Twitter. Specifically tech Twitter, not like all the politics BS. So tech Twitter has like probably some of the brightest, most overachieving, like best people I know, doing all kinds of interesting startups. Like I was just in LA, and like there's this guy making like a metal 3D printer from scratch. There's like another guy, and they're building like ion thrusters for spacecraft. Like my age, like not like big companies, but they're starting out, and they're doing so many cool things, and they reach out to me, I reach out to them, and it's probably the least stigmatized place to meet people that I've ever seen, and specifically the Bay Area has been in my experience, but it's, I think most major cities. And yeah, I think that's probably the place I've met the most talented people in this space, for sure.
Yeah, I agree with that. Like a lot of cool connections I have had has been through Twitter. I go to a co-working space recently in Toronto. Right. It started with Twitter, so I definitely agree with that.
Okay, yeah. So I think probably my favorite books, and I'm assuming you're referring to maybe like fiction. Definitely, like I think Hitchhiker's Guide to the Galaxy is probably one of the better ones, I think. Another one that was very interesting. That I've gifted is this book by Stephen Hawking. I think it was called. Wasn't Theory of Everything. Let's see. It was a blue book. It was called. Brief Answers to the Big Questions by Stephen Hawking. And that book was really interesting because it kind of sparked a lot of like internal debates, and like what even are all of the core concepts we know. Like, for example, like one of the concepts I found really profound was that like if we could have a simulator that could that was the most compute ever, and we knew the initial state of the universe from the Big Bang, we would be able to actually predict the present, past, and future. Or like it kind of does like one of those like kind of mind questions, like whoa. And so that was like probably like one of the more interesting books. But yeah, I think a lot of my time, honestly, so I started out with like a bunch of textbooks too, learning what I'm doing. But I think the problem is like I'm trying to learn really quick, and I think the easiest way to get the most amount of bandwidth in the least amount of time for me personally has been like lecture videos. I just put lecture videos on like 2x, and I just like write a bunch of notes and learn very quickly that way. But if you're just trying to like kind of on your leisure, like, yeah, all the time, like I think those books are very interesting to like spark like mental.
We're on the topic of, I think you touch a bit about learning and how you use these lecture videos. I'm curious, like what is usually a learning process for you look like?
Right.
Like when you're trying to, for example, learn a skill, how do you go from the start?
I'm actually really good at that, so I can answer. So the first thing I do is establish what are the inputs and what are the outputs, and what does generally the system you want look like. Once you can do that, it's just a matter of like understanding that system. So usually it starts out with like, okay, there's an input-output black box. And you can literally just say that black box is f of x, and that's what I'm trying to understand. Once you can define the inputs and the outputs, then you've actualized exactly why everything makes sense to the main function. Then you start breaking that function down into like smaller functions that feed into other functions. So, for example, I started like, okay, I want to make a jet engine. Okay, what are the components of a jet engine? There's a compressor, combustor, turbine. Okay, let's kind of like narrow in. Okay, what do you need for a compressor? Okay, you have a rotor that turns, and you have a stator that's stationary, and this thing turns, and the stationary blade causes a pressure rise. So, okay, what are the shapes of these specific blades that cause it to actually cause this pressure rise. And so you kind of keep going down this rabbit hole. And then once you've finally gotten the output of that function, so in my case is what are the blades and the angles and the shapes, then you start going backwards and be like, okay, now I've kind of gotten the outputs of this, and this feeds into the combustion chamber. And you kind of keep doing the same approach where you kind of go in and back out, and then understanding everything until you finally get to the output that you actualize at the very beginning. But I think it always starts with like identifying what are the inputs and what are the outputs. In my case, the inputs was like a spec of what you wanted your compressor to be, and the output is literally the CAD. And so what is the function in between that you get to that? And so that's I think how I learned the best, is like actually understanding the system at a high level and then going in at an intricate level.
That's super cool. So it's basically like breaking down the structure of what.
Yeah, it's called. There's a name for this. It's called decomposition, and it's actually a very big thing in computer science. Like for example, classes have subclasses and polymorphism and all this other stuff. So this is a very known concept in computer science, which is how you can break like really big problems down into like really small, more manageable steps.
Mm-hmm. It's super cool. And I want to ask, like, while in the process of learning things, when you find yourself a bit unfocused or distracted, because I'm sure everyone does at some point, how do you tackle that? And
I am very interesting in how I do that. Okay. So I watched this movie called 2001: Space Odyssey, and I 100% am saying this for myself, but like after watching that, I'm like, my motivation is like 100x what it was. Like I can go back and like be like, okay, this is what I'm doing. This is why I'm doing it. And this is like, I'm very passionate. So I think finding like, you have to like think in your mind, like, why am I doing this? And like at a high level, like, why is it interesting? And for me, it's like seeing a space plane in my head is like what motivates me. It's like, this is the coolest thing ever. And so that's kind of how I view it as a motivating factor. I might not get there anytime soon, but it's definitely a very motivating thing to think about, to like tackle smaller tasks that could potentially either get you or like someone else, since this is open source there. So that's something in my head that really, like, keeping the really big idea in mind that excites you the most. There's been some pretty low points where I've wanted to quit altogether, and definitely establishing like a grand vision that excites you is a really great way to just wake up every day passionate about something. So yeah,
I really I admire that, because I feel like when everything's falling apart, that why you have for yourself is what like pushes you through, pushes you against all things.
Right.
And yeah, I definitely admire that quite a bit. Dude, how many times have you watched 2001: Space Odyssey?
I want to say at least 40 times. Maybe not all the way through, but there's a scene at the beginning where like the space plane is coming from Earth and like docking with the space station. And that's like maybe like 20 minutes or so. But like that specific scene, I've probably seen like 40 times. So yeah.
I really like that.
There's also there's also a lot of music I listen to, like I think it's called like Test Flight Starfish, that makes a lot of like space music, and just like various like other composers that make like space music, like Interstellar, all that. That also motivates me a lot to like really put the vision in mind in my head of like what I'm trying to work towards here.
Cool. And I want to ask, this is I asked this question because I've found this to be very consistent with other people I've talked to, and every single creative person I know, like who's working and building things, they go on a lot of walks. Do you do that,
yeah.
or do you like?
Yeah, for sure. Like legit, I the other day walked for like 3 hours. I cannot think without pacing personally, and I get a lot of my inspiration and like motivation from like just going on really long walks. So that's definitely like a really big part in my daily routine for sure.
How often do you go on these really long walks?
Every day. Like I'm probably going to go after this call even.
For 3 hours?
Yeah, maybe not. I kind of overdid myself yesterday, but probably like usually an hour and a half, 2 hours.
That's really good, and
Yeah,
that's super cool. You're able to find the time for that in
yeah,
your day. That I agree with that, and I relate with that quite a bit because I feel like I started getting really inspired, and I really started working hard in my life when I started to go on those walks. Because you start to like you mentioned, you start to think of those whys that, like,
yeah.
why are you doing that? Why do things matter
I
for
think
you?
yeah, I think at your desk you can get like really tunnel visioned, and so just going for a walk, you can kind of really put everything in perspective. Like you kind of zoom out of everything you're doing. It's like, okay, why am I doing that? And then why does that matter for this? And then eventually you come to the understanding of everything, and then you come back more like fresh headed at the problem. So
Mhm.
yeah,
And I'm guessing you don't listen to any music or podcasts in your walks.
I mostly listen to music that inspires me. I don't listen to like
Cool.
Drake. I mean, Drake's for the gym, but like I mostly listen to like inspirational music, like that is usually something that motivates me.
Cool, super cool. And I want to ask, like, you touched a bit on about like there's been times when you almost wanted to give up, and that's when you like watched 2001: Space Odyssey.
Yeah, yeah,
Connecting from that question, I want to ask like, how's a failure or apparent failure, like a very specific ones, set you up for later success? Like that you would call
yeah.
your favorite failure of yours.
Right. I think so. I think it definitely. So actually, before it's funny you say that because before this project, I was actually trying to do this thing where I was trying to like land like a weather balloon, like a SpaceX rocket. Like so, you would use like venting of the balloon to control like how high it went, and then it had like this like fan, and then these fins that would redirect the air. And this is all on GitHub too. And I eventually came to the conclusion after doing enough like kind of simulations that like this thing would get just blown away by the wind. Like it doesn't matter like how powerful this fan is, like if it even could be that powerful. Like there's no way that you could have made something that would do that, especially since balloons are very light and they're just how fast the wind is up in high altitudes. And so that was technically like a failure because I never really finished that, and it wasn't something that even seemed feasible at the end.
Mm-hmm.
But it was definitely like a great thought experiment that led to a lot of things down the road. Like I learned a lot about like simulations actually through that, or I learned a lot about how to even like start a problem that complicated, and being able to break it down into like something manageable. And actually, a lot of those elements that I learned translated to this project. A lot of actually code, even from that, translated over like altitude pressures and all kinds of stuff. So I don't really view things as a failure more so than like, I mean, this has been said a lot, but like a learning experience, because I'm sure that specific thing was like, didn't turn out the way you wanted it, but you did learn a lot of skills. You did learn a lot about yourself and how you work and how you can target problems and finish them. So I think that's something that to keep in mind, even so when something doesn't work out.
Mm-hmm. I get that. It's like when you do get a failure, it's almost always that it does like give you some value. Like it doesn't matter. Like like you mentioned, sometimes not even a failure. It's just like a learning experience that you get quite a bit from. Like I know for a fact that there's been assignments that I've completely flopped in, and this is like a very basic way of saying it, but just like in the assignments that you flop and you learn things from it. So
Yeah,
100% agree with that having the
yeah,
growth mindset.
for sure.
And I want to ask like, what would your advice be for young people who are like trying to do big things? Like think of like one random person from tech Twitter who's like super young and he's trying to like build cool things. Like one, what advice would you give them? And second, what advice would you tell them to ignore?
Yeah, I think the biggest thing is like that I've learned from this whole process is like don't let someone, even though that they have experience, like I guess gatekeep what you're trying to do. Like I've had a lot of times when I was starting out where I was like, oh, this 22-year-old thinks he can do better than SpaceX or some stupid thing like that. And at that point, like I've probably done more work on this type of problem from scratch than he's probably done in his career. And a lot of people will kind of like pointing that out to him too. Like, okay, sure, this kid isn't like the next SpaceX yet, but like he's still done something very impressive. So I do see this a lot more in engineering than I do in software, but there's a lot of gatekeeping. So don't let someone, just because they appear to have some level of expertise, to kind of shun you in what you're trying to do. Obviously, like sometimes it's like kind of hard to tell the difference between like giving good advice and gatekeeping. So you kind of have to keep like, you know, an open mind too. Maybe this guy actually has a lot of experience, has done a lot of what you've done, and said like, this is not going to work objectively. Like the laws of physics don't allow this to happen. So being humble going into it is also very important. But sometimes they're just being like just quite frankly assholes, you know. So I think it's good to go in with like a humble approach to like a very hard problem. And you know, if someone that does have experience is just criticizing for the sake of criticizing, just take that with a grain of salt. And actually like talk to more people that encourage you has also been like another thing that's really been big for me. There's been a lot of people I've talked to doing like really interesting projects, big projects, and kind of surrounding you more with people that are more supportive is also something big. Also try to surround yourself with people who've actually done the thing you're doing, because that can actually really help understand like what the problem you're trying to do. Is it possible? How do you pivot? Because a lot of times maybe you do need to pivot. So I think that's like the biggest thing, the experience I've had. Don't let people that haven't done nearly the amount of work you have discredit what you're doing just because you're just starting out, for sure.
I'm guessing you encountered that quite a bit yourself.
Yeah, like I put out a lot of stuff I did on Reddit, and I got a lot of negative comments. But eventually I have like researchers using the same tools at like big universities. So I think it's important to keep that in mind, which is like, you've actually put in the work and some stranger is criticizing it that probably hasn't done nearly the amount of work you have. But maybe they have more experience, like seeing it in industry, like at a high, like maybe they just use ANSYS. They don't actually know how ANSYS even works. So I think that's something to keep in mind.
And ANSYS is the
simulator tool. Yeah, ANSYS
Nice.
is like a simulator. I'm actually trying to make a simulator from scratch, which is its own thing.
Yeah.
But yeah, like maybe they've used ANSYS at a high level, but they don't actually know how it works, which I actually do now at like a intermediate level to intricate levels. So yeah.
Yeah, I agree with that, because I feel like I think I came to a point in my life, and maybe you can relate to this. It's like after you put in a lot of work and you do get some sort of results out of your work, like other people outside in the world do seem to value your work. I think you get sort of that self-esteem that you are building cool things, that you are doing things that are good. And if someone criticizes you, it's like, it's just one of the things that maybe you can improve, or maybe they
I've noticed
actually
I've noticed a lot recently. I've gotten a lot less like negative comments. Now if I go to like, for example, r/CFD and show something I've done, they're like, wow, you're doing God's work. I was like, that wasn't the response I got when I started. So that's all I have to say there. I think it's really easy for someone to criticize you just because you're a beginner, and just don't let that get to you too much, for sure.
I like when I was like in March of this year, I was like reaching out to a bunch of internships, and I barely have any work experience right now in my first year. And I did get some reply backs to my emails being like, well, you do not have experience, like at all. And they were like incredibly demotivating sometimes, but I feel like at one point I got to a stage where it was like, well, it's just one person out of like the 40 emails I sent. And like, there's been some emails that I got back that were like, people were really appreciating. It was like the complete opposite of the negative email. So 100% agree with that. It's like,
just listen to more of those. Yeah. I think
like just putting yourself out there and just like taking everything and just like still having like a stand for yourself and just keep working towards what you're building or whatever you're working on, I feel like that always has like exponential amounts of returns because you actually like people see your growth.
Right.
Yeah.
Yeah, exactly.
Mm-hmm. And another thing I want to ask is, in the last 5 years, what new belief, behavior, or habit that you think has most improved your life? And feel free to think about this for a bit.
I think for me personally, it's been like waking up early and going to the gym every day, for sure. Waking up early, I think it's very understated how much of a benefit that can have. In college, I would always wake up at like noon or 11 a.m. I'd always get classes later in the day. And up until recently, I also woke up really late. And I think that the difference is, I think early in the morning and late at night, I kind of get this feeling of like Zen, where like you can actually like no one else is really bothering you, and you can kind of really think. And it's very quiet, and I think that's a very, and also it just gives you a start in the day. Whereas like I feel like you kind of feel terrible that you woke up so late and you're just starting the day at like noon. So that's the other thing. And then the gym part is like really improved mental health, like orders of magnitude. And I think that's probably like the biggest one for me.
Mm-hmm. Yeah. Like, how do you think gym helps you with like your other because I'd say your true passion, or correct me if I'm wrong, your true passion would be like to improve these rockets or make these simulators and make space accessible. So how do you? Yeah,
so like it's almost like the same way with walking. Like I think it's very therapeutic when you're like you get like really anxious and overwhelmed. It is definitely a relief mechanism for sure. Like it allows you to kind of like relieve that anxiety, so you can kind of go back to a problem. Like I've had a lot of times where I've just like really gotten anxious sometimes learning some of these things, and being able to kind of step back and doing something, and like exercise is really good at like relieving anxiety. And I think that's like a really good way of doing it for me, at least. So that's in my experience. Like every time I'm anxious when I'm like sitting at my desk, I go to the gym. Like I go multiple times a day sometimes.
What kind of exercise would you say you do the most that relieves your anxiety?
Probably like mostly weights for triceps and biceps stuff. But you know, like squats sometimes, like that kind of like we have like machines for like bicep, tricep curls, all that kind of stuff. So I think that helps the most.
Yeah, and I'm sure you're listening to Greg in the gym then.
Oh yeah, for sure.
Nice. And this is again a very objective question, and feel free to think about this, that what purchase of $100 or less has most positively impacted your life in the last 6 months or recent memory? My audience usually loves specifics like brands, model. I'll probably drop a link of the thing you said in the episode.
Right. I think for me it wasn't 100, it was actually $239, but it was probably the biggest impact. So there's this course by this guy, his name's Dr. Aidan Wimshurst. And he made this whole lecture series of like literally how you like start with like force equals mass times acceleration all the way to like running a simulation. And he just goes through like every step intricately and like exactly says how he got there. And then on top of that, he gives you the code in Python and MATLAB of exactly how you implement the simulators. And so I think that has probably been like the best investment I've made. Also, probably this fluid mechanics book I mentioned earlier was also very helpful. I think that was only like, I got it used for like $50. Yeah, I think those were the main two for me.
Mm-hmm. I see you don't mention like some of the other people I've interviewed or just have a conversation with. They talk about specific things like standing desks, or they talk about something productivity related.
Yeah.
And I think it works differently for everyone. I'm just curious, what's your opinion like on changing a bunch of these productivity environments? Because I came to a point where I realized that I was switching my, like I was putting demands on doing things like, oh, having a standing this would be nice, or having a nice microphone for starting my podcast would be nice.
Yeah.
And, oh, I should also get a DSLR. Do you ever get to a point that you feel like you're almost always jumping a lot of gadgets?
I actually think that like mainly the biggest thing with me has been like it's been more of a knowledge gap than like a gadget gap that has affected my productivity the most. Although most recently I got like an M2 MacBook, and that has like been a complete game changer because like I'm running these sims like butter, and like there's no fan. Fans make me very anxious, and I didn't even realize that until I got this. And yeah, like I definitely think gadgets can make your life easier for sure. Like definitely like one thing my mom always said that I think it's like a very good point of wisdom is that like get the things of your trade, like get the best things. Because like if you're going to be using something a lot and that adds the most value to your life because you're using it so much, like get the best. And I think that'll pay off both in time and effort in the end. So, right.
Yeah, I 100% agree with that. Like I never discount on things that I use every single day. Like for example, I don't discount on my laptop, or I don't discount on, well, yeah, mostly my laptop basically, and just getting a good lamp. But I think what I'm connecting to is, and what I got from you is, you mentioned the most gaps for you have been knowledge gaps. And I relate with that a lot because a lot of times I feel like you're always optimizing for that 5% of like getting a new gadget. And I see that because I see people always saying that, oh, if I get that gadget, my life would be completely changed. And I think even looking at you, I feel like I realized that a lot of times it's just like putting the hours for the things that you know you're passionate about, and upgrade gadgets that you like as you upgraded your Mac.
Yeah,
but
I remember I had like a violin teacher, and he was saying like it doesn't matter if you had like a Stradivarius violin or like some cheap violin. Like at the end of the day, it's the player, right? So at the end of the day, I think a lot of it is just the knowledge gap, and the tools make your life a lot easier for sure. But that's I think even with me, like I've been using this 2015 MacBook Pro since high school, and it's provided like a lot of value even till now. But I think definitely, gadgets can help with productivity enhancement, but it's not the biggest factor in my opinion.
Yeah, I 100% agree.
Yeah.
And
yeah, I think in general, it's like when it comes to a lot of religious things, like I'm not really into that kind of stuff. So that's probably been like the number one thing. Another thing is like there's like a lot of cultural things that I don't really agree with. But that I think most of like the high level like teachings that I've kind of gotten have been useful for both being a good person, but also like impacting like how I view things. So I think that's mainly it.
Cool. Anything in specific that you feel like that relating to your culture that you think that you eventually chose against following?
Yeah, there's like a lot of things in like, for example, Persian culture. Like there's this thing called Taruf where like, you like someone offers you something and you say like, oh, don't worry about it or whatever, but you actually do want it. It's just I'm very straightforward, so I don't really care for this kind of traditional things. So yeah.
100%.
Yeah.
Oh yeah, I get that because like even in Indian culture, there's this thing. I mean, it's not really exactly a thing, but it's just like sort of a norm that whenever it comes to your home, you tell them that, well, feel free to come whenever, and like
you don't actually mean it.
Yeah, like
it's a very Eastern culture thing, I think.
Yeah, yeah. Like I got to a point where like if I was like living at my own place, I would not say that, but I didn't mean that. So 100% agree with that.
Right.
Yeah, super cool.
Honestly, I don't think I can even think of that too much. I in general, I haven't really gotten too much bad advice that I can even recall.
That's all.
At least at a professional level.
What's Well, let's jump to the other part then. What's the bad advice that you have heard that from personal or like just lifestyle type of?
Well, I guess this can kind of factor in, but sometimes, like, I think my dad is very much like, you always need to fight everything. And I don't think that's always worth it. Like, sometimes things just aren't worth fighting over. And it's just easier to just let it go. And it's easier to just like save your own time and frustration than going through this long road of fighting something. So I think that's the biggest takeaway that advice wise that I've kind of not really agreed with.
Is there a story behind that?
Yeah, there's like this time I think like I was like riding a bike and like I didn't make a full stop and like I could have just paid like $50. It wouldn't have gone my record or anything. But like we spent like the whole weekend like trying to go to court and say like he technically did stop and this and that and like wasted all of our time. Eventually like the judge wasn't going to be there for another day. So we're like, all right. And then we end up going and eventually like apparently they screwed up. I ended up having to pay more money in the end. So I think after that I was like, okay, I rather would have just paid the $50 and saved my own time. So I think like at the end of the day, like I value my time more than my money, which is something that I took away from that.
I actually get that. I relate with that, and I feel like maybe at least I've seen it's like again touching back on the Eastern culture thing. Yeah, I feel like it's one of the things that I've seen in Eastern culture is that like in Eastern culture they value money over time a lot. And yeah, I feel like I relate with that and I get that in the sense. Last question, straightforward, very vague. What truly makes you happy in life?
Truly makes me happy. I think the biggest thing is just working on things that I'm excited about. I was at a job where I wasn't very like passionate about what I was doing. And I was pretty depressed then. And I think as soon as I left and just like had time to like learn things that I was very passionate about, had time to go to the gym like multiple times a day, like had time to work on things that actually inspired me. I think that I'm like the happiest I've been in a long time, I think recently. And I think that's the biggest thing is just at the end of the day, just doing what you want. And like kind of starting, if you want to start a business, go do it. Like, especially like your audience, like they're probably in their early 20s or younger. Like this is the time in your life, I think, where you actually have the most amount of potential to do anything you want. You don't have a wife to support. You don't have a kid to support. You don't have to pay off a mortgage. You don't have to worry about anything. You literally can do a lot of things that later down the road, you're not going to get the chance to. So I think that's the biggest time to kind of explore personal growth. And like, that brings me the most happiness, I think, which is like actually going and doing things that I've always wanted to do. Yeah.
Point being, I feel like what you're saying really relates to me. It's the sense that your 20s are to make these crazy moves because I lost like $300 for the flight. Yes. Do I have a lot of money? No. But am I going to make that money back truly somehow? Yes. So right. I think I've definitely started to value that. Like this is the time. Thanks so much for being on the podcast. And yeah, like I hope open our eyes.
Thank you so much for listening. It means